Now today we are going to study calculation of GM, guys. Listen my words carefully. Today we are going to study calculation of GM. What is the meaning of GM, guys? Before going further, what is the meaning of GM? Metacentric height, correct? So calculation of GM for small change in draft. For what purpose we are going to study? Calculation of, for what, guys? For small change in draft, guys. Listen, give this heading, guys, everyone. Before going further, give this heading, calculation of GM for Now try to understand the scenario, guys. Yesterday we studied one more thing. One thing, guys, we studied yesterday. What is the meaning of B that we studied, guys, in our last lecture? What is the meaning of B that we studied? Center of buoyancy. What is the meaning of B? Center of buoyancy. That is the meaning of B that we studied on yesterday, guys. B means what? Center of buoyancy. Now, what are the meanings of center of buoyancy, guys? There are two meanings we studied on last lecture. Center of buoyancy means what, guys? What are the two meanings about center of buoyancy we studied? Tell me. What are the two meanings of? It is the point. It is the point. It is the point through which buoyancy force acts upward. Okay, this is the meaning that that is the meaning of that B we studied, guys. Then after that, so this is another meaning of B. What is the geometrical meaning of B? Can you tell me? Geometrical meaning. What is the geometrical meaning? No, you are not saying correctly. Say it properly. Last sentence. No, wait, guys, see, weight of water displaced, that is meant by buoyancy force. Guys, don't get confused. Weight, see, what is the basic definition of buoyancy force? Buoyancy force means what? Weight of water displaced. That is, but geometrically, last sentence that I have given you related with center of buoyancy. Where we will get a center of buoyancy? Correct. Yes, correct. What is the geometrical meaning of the center of buoyancy? It is what, guys? It is the centroid of water displaced. It is the centroid of volume of water displaced, guys. That is the meaning that we studied. That is the meaning that we studied on our last lecture. See, what is that? Centroid, guys. Centroid of what? Volume of water displaced. Centroid of what? Centroid of volume of water displaced, guys. Now volume of water displaced means what, guys? Try to understand my point here. Suppose here I am showing you guys a transverse view. Which view we are looking here? A transverse view, guys. And just take one rough drawing. Just here we are looking at the transverse view. Just have a look here. And this line denote what, guys? Tell me. What this line denote? What this line denote? Water line, guys. This line denote what? Water line. So now if you observe here, guys. So this is what this area denote? Tell me. What this area denote? So water displaced. So no, this is not area of water plane, guys. Water displaced, guys. What this? Water displaced, guys. And centroid of this area. Centroid of this area will be what, guys? Tell me. What will be this? it center of buoyancy. It is the centroid, guys. Listen my words carefully. It is the centroid of water displace will be what? Centroid of what? Water displace will be what? Center of buoyancy. Now try to listen my words carefully. What we have to do and how we are going to approach the things further, guys. What we have to do. See, first of all, before going further, how to get a centroid, guys? Centroid of any area. How to get a centroid of any area, guys? Suppose there is a, see, try to understand my point here. Don't write anything. Just try to understand the things here carefully. Suppose this is one figure, guys. Try to understand my point. This is what a one figure, and our target is what? We have to find out centroid of this figure. Centroid of this figure with respect to, there is a one axis at the bottom. There is a one axis. This axis is visible at the bottom, guys. Okay, so this is our axis which is available at the bottom, guys. So this is what, just imagine that this is an axis. We will say it as a x-axis. Just for a sec, guys, how to get a centroid. I'm just telling you guys one basic concept, how to get a centroid of any area. See, this total area consists of what? Two parts. This total area consists of what? Two parts. First part is what, guys? This is part 1, part 2. And we want to calculate overall centroid. So what we are going to do? We are going to calculate what? First of all, this part 1 centroid somewhere here, guys. Part 2 centroid somewhere here. Guys, observe the things. So part 1 centroid we will say C1. Part 2 centroid somewhere here C2. C1 and C2. So part 1 centroid. This is part 1 centroid. Part 2 centroid C2. Suppose this distance, guys, observe. I'm going to draw one dotted line. One dotted line from here. Suppose just we will imagine this distance is what, guys? We will imagine y1, and this distance we are going to imagine y2. So this distance is y1. This distance is what, guys? y2. Try to understand my point here. And how to get, suppose centroid, overall centroid somewhere here. Overall centroid somewhere here means it is a, what is meant by centroid? Basically centroid means what? Suppose United States of America or any country. Suppose you take a example of UK. Suppose this is a UK. And if you want to represent UK by a single point, how you will represent UK by a single point? Centroid. Centroid will represent what? If you want to represent UK, United Kingdom is a big country, and if you want to represent United Kingdom by a single point, centroid will be that representation point, guys. Means suppose UK consists of what? England, Scotland, then Wales. So suppose this is what? England, Scotland, then Wales, I think Ireland also, no? So suppose, so, and these are the four. England is one part, Scotland is one part, guys. So different part of the UK. Scotland, Wales. So these are the different parts of the UK. Now try to understand the scenario, guys, here, everyone. So England, Scotland, Wales. So, and see, Scotland centroid C1, England centroid C2, Ireland centroid C3, Wales centroid C4. Same way, guys. And then overall centroid will be what, guys? Here somewhere here overall centroid. Same thing with the same thing will be this with this drawing also, this figure, this area. So here part 1 centroid y1, part 2 centroid distance from this x-axis y2. So, and we want to find out overall centroid. How to get the overall centroid, guys? Then what will be the relation, guys? Try to see the scenario. What will be the relation of the overall centroid? This is just for our understanding. So overall centroid y. Overall centroid from this one, guys, we will say y. So overall centroid will be what? y will be what guys? A1 y1 a plus a2 y2 divided by what? A1 plus a2. So this is the way to get a centroid guys. Okay, now in place of centroid, guys, try to see the centroid. You studied what is meant by centroid. Now just we are going to take an example of ship, guys. Now we will take one example. Guys, don't write anything, and I will explain you. Suppose, try to understand my point. This discussion is quite important for us. Suppose here I am showing you a transverse view. Suppose initial mass of the ship, initial displacement of the ship is what? 10,000 ton. How much initial displacement of the ship? 10,000 ton. And kg. Kg means what? And kg of the ship is what? Just imagine that 5 meter. Kg means what? Initial distance, kg. And we are going initial distance of center of gravity from the keel, and now we are going to, this is the initial situation, and we are adding a mass of what? We are adding a mass of 100 ton. That mass that we are adding, we are adding a mass of 100 ton somewhere here. So we are adding a mass of what? 100 ton, guys. It's kg, mass kg, guys. See, there are two denotion. If you are showing by capital kg, means centroid, means that will be for the ship. Okay, see, whenever we denoting by capital means for what? Guys, tell me. Is for ship center of gravity. And small means what? That particular will be that that mass added, and that center of gravity of mass will be that. So kg, that is correct. The mass that that we have added, guys. So its kg is, just imagine that its kg is what? 7 meter. And how to get the final centroid, guys? Now G basically is nothing but what? What is the basic meaning of G? G means what? In general words, we can say centroid of mass. See, in earlier we have seen centroid of area. Here we have seen in this example what we have seen? Centroid of area. Centroid of area is what? A1 y1 plus a2 y2 plus a1 y1 plus a2 y2 divided by a1 plus a2. If there is a 3 areas, then here we can take a3 y3. Suppose 3 areas there. Just imagine that we added one extra area. But a3 y3. But we have taken only 2 areas, so that's why I am erasing this portion. So now same with the mass. Suppose we want to calculate the set. So what is the meaning of center of gravity in generalized terms? Center of gravity means what? Centroid of the mass. So how to get a kg final, guys, there? How to get a kg final? How to get a kg? See, instead of area, here we will have a mass delta into its kg plus m into kg divided by what? Just compare this relation with this relation, guys. Instead of area 1, initial displacement. We are adding how? Here this, instead of A2, what we have, guys? Here A2, here what we have? Mass added. Here we have what, guys? Mass added, and divided by what? Tell me. Delta plus m. And delta plus means means A1 plus A2. And in this way we will get a what, guys? So see how to get a centroid of anything. Centroid means in different scenario centroid will have a different meaning, guys. See, in different scenario centroid will have a different meaning. Means what? Centroid of mass. Centroid of mass means what? Center of gravity. Centroid of volume of water displaced. Centroid of what? Volume of water And what is the meaning of centroid of volume of water displaced? Guys, tell me. Centroid of volume of water displaced. What is the meaning of centroid of volume of water displaced? No, guys, you are not. kg? Guys, you are not studying. Guys, see, attending the class is not the only thing. You have to study also. Just few minutes before we have studied the things, guys. What is the meaning of, guys, few minutes before we have seen. Center of buoyancy, guys. Why you are saying kg? Why you are saying kg, guys? You have to study, guys. So, centroid of volume of water displaced will be what? B. Okay. So, guys, what is the meaning of G? What is the meaning of G? Tell me meaning of G, guys. I want exact words. What is the meaning of G? Center of gravity. What is the meaning of B? What are you saying? You are not saying proper words. If you are saying such type of center of gravity acting vertically downward, is it the proper word? G means only center of gravity. What is the meaning of G? Guys, see, if you say such type of words in your oral, they will fail you in oral. Guys, so you should be specific. So what is the meaning of G? What is the meaning of G, guys? What is the meaning of B? Center of buoyancy. Guys, you are getting my point? And center of buoyancy is the point through which buoyancy force acts vertically upward. Center of buoyancy is the buoyancy force. It is center of buoyancy is the point through which buoyancy force acts vertically upward. So that is meant by center of buoyancy. Now try to you got my point. Try to understand the scenario. Now why I am explaining you all these things, guys? Why I am explaining you how to get a centroid and all these things? See, I am explaining you once again. What is the meaning of G? Tell me. G means center of gravity. And basically, it is the center of gravity is nothing but the what? Centroid of mass. Guys, you got the meaning of G? G means what? Basic meaning is what? Centroid of gravity. But means if you see practically, it is nothing but what? Centroid of mass. Generally, we can say. And what is the meaning of B? What is the meaning of B, guys? B means what? Center of buoyancy. And what is this one, guys? Centroid of volume of water displaced, guys. Centroid of volume of water. See, guys, it can be liquid also or fluid also. But here our discussion is related with ship. So we will keep water only. So now why we are explaining all these things, guys, and why it is important for us, because our upcoming discussion is totally based on this one, guys. So now try to understand my point. Here I am going to draw one drawing. Transverse view of the ship. What I am going to do? I am going to draw the what? Transverse view of the ship. Guys, observe the scenario here. I am going to draw the transverse view. Observe. Don't write anything. Just listen my words carefully. Which view I am currently showing here? Transverse view of the ship. Here I am going to show, guys. So transverse view of the ship. Guys, observe. So this is a transverse view. What this line denote, guys? Tell me what this line denote. This line denote what? Water line. Initial water line. From this point I am going to draw one dotted line from here. From here, guys, I am going to draw one dotted line. What this dotted line denote, guys? Can you tell me? That is the keel. That is the keel line. That is the keel line. And guys, and the next point is what, guys? What this distance denote? Can you tell me what this distance denote? Draught, guys. That is the, don't say depth, guys. Depth means from deck of the ship to the keel. That's only draught, guys. Small d. That is its initial t. Suppose we are adding a mass m. What we are going to do? Okay. So what we are going to do? We are going to add a mass m. Let M will be equal to what, guys? Mass added. Mass added in ton. What we are going to do? We are going to add. When we are going to add a mass, what is going to, and see, initial center of buoyancy, guys, listen my words carefully. Don't write anything. Just try to see the scenario here. What this line denote, guys? Can you help me with this line? What this line denote? Center line, correct. This line denote what? Center line. Now here, guys, this point I am showing here currently. What is this point, guys? Can you help me with this point? This red dot point. What this point denote, guys? Center of buoyancy. And its distance from the keel, guys, its distance from where, guys? Its distance from where? From the keel. What that distance denote? Its distance from the keel. No, not center. What is this distance? And what is this? What this distance denote, guys? Tell me. Center of buoyancy. That will be KB, na, guys? Simply straightforward. So now, guys, try to understand my point here. So here, so what is this one, guys? Here KB. KB means what? KB means what? Kill the vertical distance, guys. That is the KB, correct. Good. We studied all these terms in our last lecture. Now, when we are adding a mass M, what we are doing, guys? We are doing what? We are adding a mass M. So when we are adding a mass M, what is going to happen? Its draft going to increase. Draft is going to increase and we will have a new water line. Okay, new water line, and that new water line we will say it as a what? W1, L1. Guys, observe, listen my points. So now, guys, see, listen my words carefully. Whatever the mass we are going to add, guys, listen my words carefully. Whatever the mass we are going to add, suppose we are adding 100 ton mass, then this is the extra water is displaced. This is what? Extra water displaced after adding the mass. This is the extra water displaced. When we are adding a mass M, before this water is not displaced. So whatever the mass M we are adding, guys, listen my words carefully. Whatever the mass M we are adding, same extra amount of water that we are going to displace. Okay. And so centroid of this water displaced, just we will take it as a small b. Centroid of what? That extra water displaced, that hatching portion. That will be what? This small b is visible to everyone. Yes, guys, let me know. And we will say that change in draft will be what? Small h. Change in draft will be what? Small h. Guys, listen my words carefully. Change in draft will be what? Small h. So now, guys, if you observe carefully, this small b exactly where it lies, guys. This exactly small b where it lies. This small b exact. Okay, on the center line. Okay, that is not an issue. But exactly with respect to keel, exactly. So that is exactly h by 2. What is meant by? Guys, can you tell me the relation of h? Change in draft relation. What will be the relation for change in draft? Small h relation, guys. Can you tell me this relation? What will be the relation of change in draft, guys? Small h relation. What is the relation of small h? Guys, we have seen in last lecture change in draft relation. Due to loading or unloading. What will be the relation? Guys, see or no? No. Mass divided by what, guys? Yes, mass divided by TPC into 100. This is the one relation of change in draft we have seen, guys. And another relation. Okay. And another relation of H will be what, guys? Tell me. M by another relation. Okay. In meter. Okay. So that, see, guys, try to listen my words carefully. So our target is what? We have to find out final GM. Guys, see, our target is what? Now, before going further, guys, I want to tell you few more things. Just a quick revision of our last things, and then we will continue our discussion. See, suppose here somewhere here we will have what? Keel. Then here we will have what? Center of buoyancy. This will be what? Our center of gravity. And this will be what? Meta center. Transverse meta center. Okay, guys, this is the things that we have seen. Try to understand the point here. Very simple discussion. Now here, if you observe, what will be the GM? GM will be what we have seen? Km minus kg. And what is the Km? Kb plus Bm. And then minus kg. Here we will get a final expression for the GM. Now this is, suppose when we are adding a mass, guys, see, when we are adding a mass M, what we are doing? We are adding a mass M. Then kb will change. When we are adding, kb will change. Means, suppose we want to find out GM final. Then GM final will be what? Our kb will change. Then that will be kb final. Bm will change. That will be Bm final. And our kg will change. That will be what? Our kg final. And our target is what? What we are studying? What we are going to calculate in this relation, guys? Calculation of GM for small change in draft. What we are going to do? We are going to calculate calculation of GM for small change in draft. So when there is a small change in draft, how to get the GM final? GM final will be what, guys? GM final, kb final minus kg final. Means kb final plus bm final minus kg final. So now try to see the scenario, guys, here. So how to get, so we need a what? We need a what, guys? We need a what? We need a kb final. We need a kb final. We need a bm final. And we need a what, guys? Kg final, guys. Try to see for all these things. New, guys, see. So how to get a kb final? Final, guys, somewhere here we will have a what? Of our final centroid. Center of buoyancy, guys. Final center of buoyancy. So what will be the relation for kb final, guys? Basically B means what? Centroid. Basically B means what? Centroid of volume of water displays. Correct. B means what? Center of buoyancy, and center of buoyancy is nothing but a what? Centroid of volume of water displays, guys. See. So now how to get a, guys, see, few minutes before we have seen how to calculate any centroid, guys. How to calculate any centroid means overall centroid. Guys, here this figure consists of two centroid. Guys, see, observe. Up to this portion, up to this this yellow portion, centroid is B. And for this yellow portion, centroid is B. For this green portion, centroid is what, guys? Small b. Means here we have divided into two parts. And our overall centroid, we have to calculate what? We have to calculate overall centroid, guys. Listen my words carefully. What we have to calculate? And overall centroid means what? Our final centroid, guys. See, we have seen how to get a centroid. A1 y1, A2 plus A2 y2 divided by A1 plus A2. That is what we have seen, na, guys. So instead of, guys, here, see, through the B, which force is going to act? Through the B, which force is going to act? Tell me. Buoyancy force. Good. And how we represented buoyancy force? By delta. if you remember our discussion, guys, just go through your notes. How we represented buoyancy force, guys? How we represented buoyancy force at the end by delta, na? Delta in ton. No, inverse delta means at the end delta, na? Buoyancy force. So now, guys, see, when our displacement is delta, for initial displacement, where we will have a center of buoyancy at the KB with respect to keel, and we are adding a mass m. Due to mass m, there is a change in center of buoyancy, and our target is what? To find out its position, its center of buoyancy. Now we have to find out new centroid of volume of water displaced. Guys, what is our water displaced? Guys, try to understand my point. And that KB final will be what, guys? Very simple discussion. Same. KB final will be what, guys? What will be the KB final? Initial delta into KB plus mass, that is small KB, divided by what? Delta, not minus, guys. Delta plus. Correct. Good. Very good. And guys, very simple discussion. See why I am explaining you all these things, so that memorizing things, sometimes if you understand the concepts, small m, KB, and this small KB will be what, guys? The small KB will be what? D plus draft, D plus H by 2, can we say? This distance will be, guys, what? Can we say? Half of the H, means up to here, guys, it will act exactly, na? Guys, you are getting my point. Try to understand the scenario here. Good. So this distance will be what, guys? 1 minute. So this distance, what we can say? I will use different color pen so that you will get a more understanding. Which color pen? I will use green only. So this will be what, guys? Our H by. Now you are getting my point, everyone. Any doubt in this discussion? So, and in this way we will get a what? Final. What we will get, guys? We will get a final KB. So now try to understand the scenario, guys. 1 minute. Sometimes it takes a little bit time, but guys, see, we are going into difficult things now. So daily you have to revise the things. Then and only then you will get the next day concepts. So in this way we got what, guys? What we got in this KB final. See, you can understand this relation, means how you got this relation, and from this relation, this is the final important relations we got it. And what will be the unit of KB final? Unit of KB final will be in meter, guys. So in this way, see, our target is what? What we have to find out? We have to find out GM final. What we have to find out, guys? What we have to find out? GM final. And how to get a GM final? KB final, BM final, and KG final, guys. So we got it first point. Then we will take it second, and then this is third point. Okay, guys, you got my point. Any doubt? You got how to get the KB final, guys, in this. So now, guys, you have given the heading, everyone. Okay. So now, before going further, guys, what you have to do? Try to understand the meaning of. So after giving the heading, guys, what you have to do? Just write down all these things properly, guys. First of all, try to draw this drawing properly, guys, and then remaining things. Please, everyone. Now, guys, after the completing this drawing, after after completing this drawing, write down this discussion guys about KB final, everyone. Now guys, in this way what we got it, KB final. Now next thing we need what? We need a what? KG final. What is the next thing? What is the next thing that we need guys? We need a what? KG final. And see, and how to get a KG final? Same like a KB final. KG final, initial delta, it's kg. Then we are adding a mass m, small kg, divided by what guys? New mass, that is total mass guys. So in this way what we will get? New kg final. Please everyone add this new kg final in your notes. Also write down in side by side unit also guys. Please everyone add this new kg final. Now kg final, after completing the kg final guys, what we need? BM final. And BM final will be what guys? This relation you have to memorize guys. We will not go into that derivation of this relation. Just you have to memorize BM, initial BM into initial displacement divided by what? Delta plus M. And in this way we will get a BM final. You have to memorize this relation guys. We will not go into derivation of this relation. Write down this BM final relation. Now the next point is what guys? What we need? So KM final will be what? First of all, okay, we need a GM final, but before that KM final will be what? KM final will be what? KB final BM final. In this way what we will get? KM final, and then at the end our target is what? Calculating GM final, and GM final will be what? KM final correct. KM final minus KG final, and that will be KM final means what? KB final plus what? BM final. You may have studied all these things, but minus KG final. In this way we will get about guys. Okay, I will put it in two formulas, no problem. For me it is very simple. No problem, I will write it. For me I don't have to do anything, just sit. So everyone please write down these formulas. Now the next point guys, next note that we are going to study guys, everyone try to see the scenario guys. See, this point is quite important, very important guys. Listen this note, try to listen this note. If there is no loading guys, if there is no loading or unloading, what is mean by loading guys? Or adding mass. If there is no loading or unloading, if there is means only shifting of mass, only shifting of mass, only what guys? Only shifting of mass. If there is only shifting of mass, then what will happen, guys? If there is only shifting of mass, then in that scenario, then no change in draft in that scenario. Then no change in mean draft. What is the meaning of mean draft? All that things we will see in our upcoming discussion of longitudinal stability. Then there is no change in, 1 minute, let me write down proper wordings, guys. Then there is no change in what, guys? Then there is no change in mean. Then there is no change in mean draft, guys. And then there is no change in mean draft. And guys, see, if there is no change in mean draft, what will happen? Hence, position of no, GM will change. No, guys, GM will change. KM will not change. Guys, see, try to understand my point. Guys, see, GM will change because kg is changing. See, basically, try to understand my point. Try to understand my point here. Basically, our GM is what? Km minus kg. Km minus kg. Guys, try to understand my point. Here I am drawing the figure. Guys, I am drawing the figure. Try to understand my point. Just. So here we will have a keel. This is what our water line. This is what our center of buoyancy. Center of gravity. And somewhere here. Okay. It may be above, it may be below. We don't know exact pose. It can be. So generally we will take a positive, guys. So now our B is totally depends on what? Draft. Our B is totally. B is okay, then and only. So this is what our draft. So our KB depends on totally on what? This volume of water display. So if you change the mass, then and only our B is going to change. So and our BM, and guys, what is the relation of BM? See, KB depends on volume of water displaced. Depends on volume of water displaced. And what is the relation of BM, guys? We have seen yesterday. BM depends on what? I center line upon AW. And what is meant by I center line? Second moment of area about area of water plane and area of water and area of water plane. So if there is no change in draft, water plane area remains same. So I center line and AW will not change, guys, if there is no change in draft. So at the end, that's why. And what is the relation of Km, guys? Km is equal to what? KB plus BM. So when there is no change, if draft is constant, if draft is what, guys? If draft is constant, then our KB and BM remain constant. And if KB and BM remain constant, then at the end Km will remain what, guys? But G. Okay. Sorry. That's why you are confusing. Sorry, my mistake, guys. It must be KB plus BM. Correct. Sorry, my mistake, guys. That's why you are confusing. Okay. So here KB and BM. What, guys? This KB and BM will not, guys, what? KB and BM will not change. Why KB and BM? Because KB depends on volume of water displaced, BM depends on I center line and area of water plane, and I center line water plane area is not going to change. So that's why our KB and BM same, BM will remain same, and that's why KM will also remain same, guys. Only what is going to change here? Only what is going to change? Kg, guys. When we are shifting the mass, and as when we are shifting, Kg is going to change, and as Kg is going to change, GM is going to change. So now guys, at the end, concluding statement, if there is what guys, if there is what, or that is only shifting of mass, that is what we can say, that is only shifting of mass, then there is no change in, then there is no change in mean draft. Hence position of transverse meta center, hence position of what guys, position of transverse meta center. What is meant by transverse meta center guys? Can you help me? Transverse meta center means MT or M position. Position of transverse meta center remains constant. That means hence position of transverse meta center remain constant. That is, at the end we can say Km constant. Km constant. What we can say? That what we can say? Km. Any doubt in this discussion, guys? So always, so whenever there is only shifting of mass, see, if mass constant, then at the end I will say, write down final concluding statement. Therefore, if mass of vessel constant, mass of vessel constant, then what we can say, Km equal to constant, guys. Final concluding statement. Any doubt in this discussion, guys? Very simple discussion, but we need this discussion in our upcoming discussion, guys. We need these all points in our upcoming discussion while dealing with the numericals. Just 15 to 20 minutes, we will finish our theory and then we will start our numerical, guys. Okay, please write down this discussion. Yes, write down this discussion, guys. So guys, at the end, what is the next point we can write? This is the first point we have seen. Make it as a first point. And the second point, what we can say? Due to shifting of mass alone. Due to, 1 minute guys, due to shifting of mass alone. Due to shifting of mass alone. There can be change in kg, guys. There can be change in kg. So we can change, due to shifting of mass alone, there can be change in kg. Hence, what we can say? Hence, Gm can be changed in this situation. Hence, Gm can be changed in this case. Okay, guys, you got this point, everyone? Make it as a point number 1, this one, and make it as a point number 2, guys, in this note. Give the next heading, guys. Everyone, give the next heading. Angle of heel. Angle of heel due to loading. Angle of heel due to loading. Due to loading, unloading, or shifting of mass. Angle of heel due to loading, unloading, or shifting of mass. Now try to understand the relation, guys. Here, what is this relation? Tan theta will be equal to what, guys? Tan theta will be equal to, don't worry, when we will come to the numericals, we will learn more about this relation, guys. Tan theta will be equal to what? Healing moment is equal to what? Don't write anything, listen my words carefully. Tan theta is equal to healing moment divided by what? Final displacement into final metacentric height. Final metacentric height. And where, guys, I'm going to write down the meaning of each and every term. GM final means what? What is the meaning of GM final? Final metacentric height. Final metacentric height in meter. And in this final metacentric height, it includes free surface effect. It includes what, guys? Effect. What is meant by free surface effect? In few minutes we will see, guys, after this point. It includes FSE. FSE stand for what? Free surface effect. Don't worry, guys. It includes what? Free surface effect. And how it will include, I will explain you, guys. And delta final means what? What is the meaning of delta final? Final display. And this displacement must be in what? Final displacement in what, guys? Turn. Okay. So please everyone write down this relation. Make this relation in box, guys. Now give the next heading, guys. Free surface effect. Everyone give the next heading. Free surface effect. And how we denote free surface effect, guys? We denote free surface effect FSC, guys. FSC, guys, free surface effect. Free surface effect. Now try to listen my words carefully, what we have to do and how we are going to approach further. Whenever there is a liquid present on the board of the ship, guys, just suppose this is what our ship. Just imagine that. This is what our ship. Okay, this is what our ship. And this is what our water line. And just imagine that we have a big tanks on the ship. Just imagine that. This is one tank. And then we will have another tank. Just try to understand the point. What is the meaning of free surface effect? You may know this term. Just what is the meaning of free surface? See, whenever there is a water in this tank, there is some liquid is there. Suppose crude oil. Just imagine that. In this tank, what is there? Crude oil. Just imagine that. Any liquid. And we are taking the example of crude oil. Any liquid, guys. Or suppose soybean oil or sunflower oil. Any oil, guys. Suppose soybean oil or sunflower oil. So suppose some oil is there. Some oil in these tanks. Two big tanks are there. And a large amount, thousands of tons of oil there. And what is there, guys? These tanks are partially empty. These tanks are what? Partially empty. Now we will try to understand what is the meaning of free surface. First of all, we will try to understand the meaning of what? Then we will see the meaning of free surface effect. First of all, what is the meaning of free surface? So what is the meaning of free surface, guys? Free surface means what? The liquid in the tank which is free to move. If tanks are what? Guys, see, these tanks are what? These two tanks are what? Partially. Okay. Partially full. So if they are what? Partially filled, or we will say partially filled. So here, so here what, guys? This liquid is what? Free to move. These liquids are what? The liquids in the tank, if it is free to move, it means it has a free surface. This topmost surface is what, guys? Topmost surface of this liquid is what? This topmost surface of the liquid is what, guys? Free to move. This topmost surface of the liquid is what, guys? This topmost, it is what? If this topmost surface of the liquid is what? Free to move. When this, when it is free to move, guys, what will happen? If this topmost surface is free to move, what will happen? It will create a what, guys? It will create a what? It will create a problem to the stability of the ship. Means if whenever there is a free liquid, means see, if it is a free to liquid, free to move means what? It has a free surface. So this surface is what, guys? What is the meaning of this surface, guys? This is meant by free surface. Means free surface means what? That means this liquid is able. What is the meaning of free surface? Free surface means what? Liquid free to move. What is the meaning of free surface? Liquid free to move, guys. What is the meaning of free surface? Free surface means what? Liquid free to move. So now try to understand the scenario. And so whenever we have a free surface, it creates a what? Whenever we have a free surface, it creates a problem to the what, guys? It creates a problem to the what? Stability of the ship. Guys, see, whenever we have a free surface, it creates a problem to the what, guys? Problem to the what, guys? Problem to the stability of the ship, guys. It creates a problem to what, guys? It creates a problem to the what, guys? It creates a problem to the stability of the ship, guys. You got my point? So now, and this effect of free surface, and this free surface effect is nothing but a what? So this now, so you got the meaning of free surface, guys. Free surface means liquid free to move. This is meant by free surface. So whenever, see, now this stability decrease. See, basically what is meant by GM now? What is meant by GM? Metacentric height. What is meant by GM, guys? GM stand for what? Height. And what is the importance of GM, guys? What is the importance of GM? Tell me. What is the importance? Okay, it helps. Okay, it has to be positive. Okay. But what is the importance of GM, guys? GM decides stability of the ship. It decides what, guys? GM decides what? GM decides what? GM decides stability of the ship. So GM decides what? Stability of the ship. If value of GM is more, ship will be more stable. If value of GM is less, ship will be what, guys? Unstable, guys. Try to understand my scenario. See, value of G, guys, see, try to understand my point here. If G is more, if GM is more, if metacentric height is more, if GM is more, ship will be more stable, guys. Ship will be what? Ship more stable. If more metacentric height, then if value of metacentric GM is higher, then ship will be what, guys? Ship will be what? More stable. Guys, you got my point. Ship will be what? Ship will be what? More stable. Try to understand my point. So now try to understand the scenario further, guys. What we have to do. Now see, what we discuss, guys. We discuss what? Free surface effect is going to reduce the stability. What is free surface effect is going to do? Free surface going to reduce, it is going to reduce stability. And see, so by how much amount stability is going to reduce? And who is going to measure the stability? Tell me, who is going to measure the stability? GM is going to measure the stability. We are going to measure stability in case of the GM, guys. So now, and free surface effect is doing the free surface is reducing the stability. See, so guys, Now, what is meant by free surface effect? Free surface effect is what? What is the meaning of free surface effect? Free surface effect means what? Due to free surface, how much stability of the ship is reduced. Guys, what is the basic meaning of free surface? Free surface effect means what? Free surface FSC means what? By how much amount the stability of the vessel reduce. By how much amount the stability of vessel reduce? That is nothing but what? Free surface effect. Okay, guys, you got the meaning of free surface effect, guys, everyone. And because of that, we will get a new GM. See, this GM means what? Initial GM means what? Without free surface effect. So we will get a new GM, and that new GM means what? Effective metacentric height. And what is, now tell me, this effective metacentric height is a lesser or higher? Less than the initial GM. So that effective metacentric height will be what? Lesser. So new stability will be what? Initial stability means without free surface effect minus FSC. GM minus FSC, guys. You got this point? You got this overall discussion? Guys, we will write down step by step so that you will get a more clarity. But you got generalized view now? Any doubt in this generalized? Because this point is very, very important. Why free surface effect and all these things? So now we will try to write down all these things step by step, guys. We will try to understand the meaning of each and every point. So don't worry. Very simple discussion, guys. Very simple point. Free surface effect means what and all these things. Now try to understand the scenario, guys, here. Now try to see the scenario. Now don't write anything. You have given the heading, na, guys, everyone? Free surface effect FSC. Now if liquid present on the board of the ship, guys, see. If liquid, don't write anything. If liquid present on the board of the ship, present on the board of the ship. If liquid present on the board of the ship, is free to move, means whatever the liquid present on the board of the ship is free to, what, guys? Free to move. That is, it has free surface. That is, it has what, guys? It has what? Free surface. Then it is a problem to the then it is a what, guys? Then it is a problem to the stability of a ship. To the stability of the what, guys? Stability of the ship. And guys, see, try to see the scenario here. So, and this effect of free surface, and this problem to the stability of the ship, and it leads to, reduction in stability. You can write down in your own words also, guys. It is not compulsory to write down in my words. Just understand the meaning. You means sometimes you may have better English than me. You can write down in your own words. This reduction in stability. Wait. Let me first of all. So it leads to reduction in stability. This reduction in stability due to free surface. This reduction in stability due to what? due to free surface is called free surface effect. It's called what, guys? Free surface effect. And how we denote free surface effect? By FSC. Okay guys, you got this meaning of free surface effect, guys. So this reduction in stability due to free surface is called free surface effect. So what is the meaning of free surface effect? Free surface effect is reduction in stability due to free surface, guys. Reduction in stability due to free surface is called what, guys? Free surface. So before going further, guys, please everyone write down this discussion now. And then we will try to write down the relation of free surface effect after this discussion, guys. Now try to see the scenario, guys, further. How to measure the free surface effect, how to calculate the free surface effect, guys. Now we are going to try to understand the relation for the free surface effect, guys. So what will be the relation for free surface effect? That is FSC. Relation for FSC will be equal to what, guys? FSC, free surface effect, rho tank, density of liquid in the tank, INA. I will explain you what is the meaning of INA, guys, don't worry. Divided by what? Delta. So this is the relation of free surface effect, and free surface effect will be in meter, and where we will try to understand the meaning of each and every term here. What is the meaning of rho tank, guys? Rho tank means what? Density of liquid. Density of liquid in the tank. In tank can be anything, guys. Water, oil, okay? Density of liquid in the tank, or any fluid, any other fluid. Density of liquid in the tank in ton per meter cube, guys. Here our density. Now this point is very, very important. INA. INA means what, guys? I means what? Second moment of area. Second moment of area about NA stand for what? Neutral axis, guys. Second moment of area about what? Neutral axis of tank liquid surface. Okay. Second moment area of what? About neutral axis of what? Tank liquid surface in m raised to the power 4. And here neutral axis is what, guys? Neutral axis is parallel to what? Neutral axis is parallel to the center line. Parallel to the what? Center line, guys. I will explain you when we will deal with the numerical, guys. When we are going to deal with numerical, I will explain you all these concepts, guys. So don't worry. When we will deal with numericals, and you know meaning of delta. Delta means displacement of the vessel. So before going further, write down this relation of FSC, guys, and write down the meaning of rho tank and meaning of INA, guys. Now try to see the scenario further, guys, here. Now what we will get? Final metacentric height. So here effective metacentric height will be what? Metacentric height means what? That is the final after considering free surface effect. Effective metacentric height will be what? We will denote by GM effective. GM effective. So GM effective will be what, guys? GM minus free surface effect. So GM minus free surface effect. And this is what, guys? What is the meaning of this GM? This GM means what? Solid metacentric height. 1 minute, don't write it. Metacentric height. And what is the meaning of solid metacentric height? Meaning of solid metacentric height means what, guys? Without free surface effect, guys. What does it mean? Without free surface effect. Means how to get a GM, guys, we have seen. GM will be equal to what? We have seen already. Here, GM solid metacentric height. And how to get that solid metacentric height? GM will be what? Km minus Kg. And Km will be what? Kb plus Bm minus Kg, guys. You got my point? Anyone have any doubt in this discussion, guys? Got it, everyone? So before going further, guys, please everyone write down this discussion about metacentric height. And this, it must be in what, guys? Meter. Effective metacentric height, guys. Effective means this GM effective. Effective. GM suffix year. Effective. Complete heading, guys. Give the complete heading. Effective metacentric height. So please everyone write down this discussion.